Hello. So we're going to be going through my Math 221 Week 2 homework question for linear algebra. Motivation of kind of displaying this proof is that I want to get better at linear algebra. One way to do that is to know the material enough so that you can teach other people. So the question reads, in this question, you will sketch a proof that a matrix has a unique reduced row echelon form. Let A be a 3 by n matrix. Suppose A does not have a unique reduced row echelon form. Let A be row equivalent to two different 3 by n reduced row echelon form matrices B and C. And then since B and C are different, there must be a first different column as you read the matrices from left to right. Therefore, for each matrix, select that column as well as the columns to the left that contain a pivot. Then delete all the other columns, which yields two new 3 by m matrices B prime and C prime constructed from the columns of B and C respectively, differing only in their last column. Suppose B prime equals this matrix. What might C prime look like? Describe the possibilities, and by interpreting B prime and C prime as augmented matrices describing systems of equations, explain why all possibilities lead to contradictions. Okay, so the general proof idea here is that you want to prove this statement that every matrix has a unique reduced row echelon form, which essentially means that if you have a matrix, say like A equals 2, 7, 6, 5, 5, 5, 7, 5, 1, 2, 3, this will always is like augmented or something. This will always reduce to a unique reduced row echelon form, like 1, 0, 0, 0, and then like maybe like 3, 4, something like that. So this part is in reduced row echelon form, right? You can kind of tell because it has that line down. And in RREF, there are several constraints, right? One of them is that the first non-zero element of a row has to be to the right of the first non-zero element of the row above. All non-zero elements, the first ones like the pivot points, which is this and this, have to be ones, and above the pivot points have to be zeros all the way down, right? So this kind of makes it very easy for you to see kind of what the immediate equation is, or the immediate values, like the solution to this matrix is. All right. Now, the general outline of this proof is that you want to prove it by contradiction, and they make it really obvious. They have the supposition here, and then they kind of mention the word contradiction over here, which means that you want to prove it by contradiction. So the supposition is that A doesn't have a unique RREF, reduced row echelon form, right? And if it doesn't, we want to find a contradiction in that logic, right? So to begin by saying it's 3 by n, which means it's got 3 rows. So row 1, row 2, and row 3, and however many columns they want, right? So they're just making it a little general. And you want it to be row equivalent to two different 3 by n reduced row echelon form matrices B and C. This means that they have A, which is a 3 by n matrix, and then they have B and C, which are also 3 by n RREFs, matrices, right? The thing is that B and C are of different forms, right? And they clearly say that over here. B and C are different. And if B and C are different, then the first column, or when you're comparing these things, there must be a column, right, that is different, at least one, as you read the matrices from left to right. So for example, B could be 3, 7, 3, 2, 1, 1, 9, 9, 9. And C could be 373, 2, 3, 4, 1, 0, 1, right? And so what they're saying is that when you're reading them from left to right, then you're going to come across the first different column. So you're reading it here, 373, 373, okay, they're the same. Then you read 211, and you read 234, they're different, right? So column 2 is the one that's going to be different. So put a star there, all right? So then, once you find that first different column, they have to be in reduced row echelon form, right? So they have to, like I said before, they're going to have to be 1 and zeros and stuff over there, all right? So let's get on with the proof. Let's see that we notice that B prime is equal to 1, 0, 1, 0, 1, 3, 0, 0, 0, right? And if you augment this, like they say, you want to interpret these as augmented matrices. Then it's going to be 1, 0, 0, 0, 1, 0. Augment that, 1, 3, 0. Okay. If you interpret this matrix as a system of linear equations, you're going to get 1 times x1 plus 0 times x2 equals 1. 0 times x1 plus 1 times x2 equals 3. 0 times x1 plus 0 times x2 equals 0. You want to ask yourself, is this a consistent system of linear equations? Is the solution set consistent? Yes. x1 equals 1, x2 equals 3. This holds up, right? And you can write this as xy equals 1, 3. That's the solution set of B prime. Then you want to think about what might C prime look like, right? Well, C prime, like they said, are constructed from the columns of B and C, respectively, such that they differ only in their last column. And they did this in a process by selecting that first differing column between B and C, and then constructing this new matrix, B prime and C prime, that will be 3 rows and m columns, right? Which will only differ in their last column. So if B prime equals 1, 0, 0, 0, 1, 0, and 1, 3, 0, then there are 2 options for C prime. Because C prime still has to be in reduced row echelon form, then it must look like 1, 0, 0, 0, 1, 0, because the first 2 columns are the same, as I said. And the last one, it either has to be, to fulfill a row echelon form, call it case 1, pivot. You want a new pivot. And that's going to look like 0, 0, 1. Right? And you add that augmented thing because they don't want you to add that. Okay, so now you're looking at this. It's a new pivot. It has to follow row echelon form. This can't be any other number like 3 or something like that, because in reduced row echelon form, the first non-zero value of a row has to be 1, right? And the values above it have to be 0. Okay, so in this case, what you're seeing here is that x1 okay, so it's going to be 1 times x1 plus 0 times x2 equals 0. Then 0 times x1 plus 1 times x2 equals 0. And then 0 times x1 plus 0 times x2 equals 0. And you're going to want to ask yourself, is there a value for x1 and x2 such that the system of linear equations is true? Well, according to this, we see that x1 equals 0. According to this, we see that x2, there should be 1, also equals 0. But then according to this, 0 times 0, 0 times 0 plus 0 times 0 equals 1. And we know that is obviously not true, right? So no, C prime is inconsistent, okay? That's the possibility of our first contradiction. However, this is not the case. This is not the only case, right? There's another case, which is called non-pivot or scalar condition. And we see here that B prime over here, B prime is 1, 0, 0, 0, 1, 0, 1, 3, 0, okay? In RREF, since this is augmented, this is allowed, right? Because this part is an RREF, and this part can be really any scalar, right? It's just that this has to be 0. Let me show you what I mean. So the possibility is that C prime can be 1, 0, 0, 0, 1, 0, augment that, and A, B, C, right? Where A, B, C are any numbers, okay? The thing is with showing this thing is that if you want to have A and B be scalars or just regular numbers like 1, 0, 4 or 0, 1, 3, then the bottom row has to be 0. It can't be a 1, right? This wouldn't work in reduced row echelon form because the values above this would be considered as establishing like a pivot, and the values above have to be 0. Okay? And adding not only that, but it also be inconsistent, right? You can't have 0 times x1 plus 0 times x2 equal to 3. There's just no value that would make it possible. So it has to be 0, okay? And we can continue calling these A and B. Then you're going to have 1 times x1 plus 0 times x2 equals A. Then 0 times x1 plus 0 times plus 1 times x2 equal to B, right? Then we see that our solution set becomes x1 equals A and x2 equals B, which means that if you're looking at B prime and C prime, they must share the same solution set. And I know you're asking, why does B prime and C prime have to share the solution set? Well, it is because in your supposition, you say A does not have a unique reduced row echelon form, but it is row equivalent to 2 different 3/n reduced row echelon form matrices B and C. And so, if A is equivalent to B and is equivalent to C, then B and C have to be equal to each other, right? The values of their solution set must be the same. No matter how much you row reduce it, if they are row equivalent, then if A is row equivalent to B and C is row equivalent to A, then B and C must be the same. It must have the same solution set. And what you're looking at is that B prime and C prime are going to be, they're not exactly the same as A, but they are merged in the way, they're not merged, okay? They are submatrices that are built by selecting specific columns from B and C, right? Because we're talking about selecting the first different column and all the pivots to its left. The resulting matrices B prime and C prime are formed by taking those specific columns. And because they are made of columns from a reduced row echelon matrix, B prime and C prime also have to be in row reduced echelon form. And because B and C have the same solutions, then any relationship that exists between the columns of B also have to exist between the same columns of C, right? And so the logic of this contradiction is that we're looking for a situation where B prime and C prime describe 2 different sets of solutions for the same variables, even though they come from the same original matrix A, right? And so we see that we did find this contradiction because the solution set of B is xy equals 1, 3, which must equal, so this is B prime, must equal A, B, C prime, right? We already ruled out the pivot, right? It's a contradiction because this is an impossible, inconsistent solution. But now we're looking at x and y equals 1 and 3 equals A and B. Clearly not the case because A and B can be any value, right? It doesn't have to be 1 and 3. So there exists a value. You can replace this with 3 and 1. And that's not the same as 1 and 3. Right? Therefore, by proof of contradiction, the supposition is false. And the supposition is that A doesn't have a unique row reduced echelon form. And the original statement is true, which is matrix has a unique row, reduced row echelon form. And this is true. Right? So, what we're seeing here is just kind of a proof. I struggled with this for a bit. Maybe you struggled with it too. I hope I made it a little more clear. By the way, this proof, all this question comes from my homework. So Math 221, right, at UBC. In algebra, my professor is Mr. Adam Martins, Dr. Adam Martin, sorry. And this proof is credited with being from, I spelled professor wrong. This proof credited to Dr. Wolf Holzmann. Alright, thank you very much for listening. Hopefully this proof made a little more sense. Alright, thank you.